Hello friends, welcome to Study Make Education channel. Today we are going to discuss about MCQ for Mechanical Engineering part 3. So let's start. Our question over here. During isothermal process, what does not change? Our options are A. Temperature, B. Pressure, C. Both pressure and temperature, and D. Volume. Friends, as we know, in isothermal process, temperature will remain constant. So it will not change. So our right option is temperature. Now let's see some important other terms which we have to remember. For isothermal process, temperature will remain constant, that we know. For isobaric process, pressure will remain constant. Okay. For isochoric process, volume will remain constant. Well, now the most important, for isotropic process, the elastic value remains same in all direction. Okay, and having a physical property which has the same value when measured in different direction. Both the definition have same meanings. Well, next is isentropic. In isentropic process, having equal entropy, means entropy will not change in isentropic process. Well, there is a reversible adiabatic process in which entropy will not change, or we can say entropy is zero. Well, remember this thing. For isenthalpic, or we can say for isoenthalpic, both are same. An isenthalpic process where a process that proceed without any change in enthalpy represented by H, and in a isenthalpic process enthalpy will not change, and in throttling process, as we know, in throttling process enthalpy will remain constant. Okay, now let's move to the another information. For isotopes, they are known as variants of a particular chemical elements which differ in neutron numbers, like uranium-232, uranium-235, thorium, etc. Vibration isolation, it is a definition from theory of machine, and vibration is a very big field. Vibration isolation is the process of isolating an object such as piece of an equipment from the source of vibrations. Now next is isolate. We are using this word in our daily life. Isolate, to be or remain alone or apart from others. This is the definition of isolates. Let's move to the next information, which is very important for exam MCQ point of view. For adiabatic process, as we know, in adiabatic process heat transfer is zero. Keep in mind, for adiabatic process Q is equal to 0. Q is represented of heat. Now in for adiabatic process, PV raised to gamma constant. Now gamma is specific heat's ratio. It is the ratio of specific heat. Now the difference of specific heat is represented by R. Now R is a universal gas constant also, and the value of R is 8314 joule per kg into Kelvin. Unit is very important. Now over here at right side, as we can see, for air the gas constant are 287 joule per kg into Kelvin. Friends, don't confuse with these values, because over here this is the gas constant R, universal gas constant, and at right side this value 287 joule per kg into Kelvin, that is the air gas constant. So remember this both value, don't confuse. Now Cp is specific heat at constant pressure, that we know, and the value of air is 1 kilojoule per kg into Kelvin, and for Cv specific heat at constant volume, the value is 0.7 kilojoule per kg into Kelvin. So if we look for a ratio Cp by Cv, so 1 upon 0.7, so our answer should be 1.4, and that is the value for air. Gamma, the ratio of Cp by Cv is 1.4 for air, and for monoatomic gas this value is 1.66. remember this value. Now let's see for a polytropic process. Remember, for polytropic process PV raised to n is equal to constant. Now what is n over here? N is known as polytropic index. Okay, now if we change the value of n, then we have different types of processes: isothermal, isobaric, isentropic and isometric. Let's see very quickly. Over here, if we put n is equal to 1, then we have constant value PV is equal to C, and this value is known as isothermal process. Now over here, isothermal process is also known as hyperbolic process, because as you know, in hyperbolic process the product of pressure and volume will remain same in any expansion or any other process. So isothermal and hyperbolic both are same. Now for isobaric process, as we know, if we put n is equal to 0, anything raised to 0 is equal to 1. So over here pressure and volume raised to 0 is equal to constant, so P will be constant. So over here our process will be isobaric process. Now if we put n is equal to K, as we can see here, n is equal to K. Now our process should be PV raised to K, so it is known as isentropic process. Now for isometric process, n is equal to infinite. So over here volume will be superior and our process will be isometric process. So remember all these values. Now let's move to the next details. Next question. Our next question is cam size depends upon, our options are pitch circle, prime circle, outer circle and base circle. Our right answer is base circle. Now we should know what is the base circle. In this spectacular vision we can see the follower. This shaded portion is our follower, and the line which I am overlapping over here, that is our follower, cam. This is our cam and this upper portion is our follower. So as we can see over here, the circle, the starting circle, this is known as base circle, which is nomenclature here. Now another important term, pressure angle over here. So pressure angle is defined as the motion movement of the follower. The pressure angle, it is the angle between the motion of the movement of the follower and the normal to the pitch curve. Well, this is over here we can see the pressure angle. This is known as pressure angle, and over here the dotted line, this is known as pitch curve. So the angle between the angle between follower motion movement and the normal to the pitch curve is known as pressure angle. Okay, so this is the proper definition. Now let's see the colorful diagram, so we have some clear idea. Well, this is, as we can see, this is our follower and the yellow portion is our cam. Now there is also one important word over here, which is dwell time, dwell period. So let's discuss about this important term. Here we can see rise of a period of rise, period of fall, period of dwell at bottom, period of dwell at top. So first of all, what is a dwell? As we know, in this arrangement, follower will comes into the rest condition, at top as well as at bottom. So at top condition it is known as period of dwell at top, and for bottom it is known as period of dwell at bottom. If we divide or if we give nomenclature like point A, point B, point C and point D, as we can see the motion of the cam is clockwise. So from point A to point D, from point A to point D, at this path follower motion will rise. So this path is known as period of rise. Okay, from point D to point C, follower will remain at rest condition. So this path is known as period of dwell at top. And from point C to point B, this is known as period of fall, because at this path follower will travel in this direction, and from point A to point D follower will travel in upper direction. Okay, now from point B to point A, this path is known as period of dwell at bottom, because from point A to point B the follower will be at rest condition, so it is known as period of dwell at bottom. Now whatever we have discussed over here, which is already mentioned in this description, so if you want to get some clear idea, so you can pause this video and you have a brief idea about this cam and follower. In automobile we are using knife edge follower, because knife edge follower has line contact with cam, so it is very so this knife edge follower will give very quick response. Okay, these are the additional information. Now another MCQ from cam from automobile side, which is in automobile there is a crank shaft and also cam which is connected with crank. So if somebody asks that the RPM of crank shaft are 1000, so the RPM of cam should be, the option are 500, 1000, 1500 and none of the above. So our answer should be 500. Remember, cam speed is half than crankshaft speed. Okay, so remember this difference. Now let's move to the next details. Our next question is, in ECM process, electrochemical machining process, the electrolyte used is, look, water and air are not the right option, as we know. Brine solution and kerosene is used for coolant in many process, so our option is brine solution. Okay, so our right option is brine solution. Now let's see some important details. For kerosene, used as a coolant in machining of an aluminium, while in drilling and reaming is a process which is done after by drilling process. Reaming is done to slightly enlarge the hole or also to give fine finishing to the hole. In brass is known as, it is a combination of copper plus zinc. Another we have to remember, bronze is a combination of copper plus tin. Okay, remember this both very carefully, don't confuse between brass and bronze. Now over here we can see, in machining aluminium and brass we have to use kerosene or a soluble oil, or we can use dry soluble oil and kerosene. Okay, now another information that I have to show you, which is for brass. To weld brass and bronze, we have to use oxidizing flame. Oxidizing flame. This is also an important MCQ. Now there is also another flame, natural flame. Natural flame. This flame is used to weld steel, copper, and other high carbon steel, low carbon steel, and other similar metal. Now another flame is carburizing flame. Carburizing flame. This carburizing flame is used to harden the surface of satellite material. Yes, satellite is one type of material, and to harden the surface of the material of a satellite, we have to use carburizing flame, specifically carburizing flame. So remember this information. Now let's move to the next question. Well, our question over here, for domestic refrigerator working on vapor compression cycle, use the following type of expansion devices. Our options are: A, manually operated valve; option B, thermostatic valve; option C, capillary tube; and option D, electrically operated throttling valve. So our right options is over here, capillary tube. Remember, in domestic refrigerator, capillary tube is the right answer for expansion devices, but in industry level, the expansion valve. Industry level means for heavy plant. Expansion valve is used as an expansion device. Over here we can see this is the expansion valve. Okay, but for our domestic purpose, this is the refrigerator. For domestic purpose, as we can see, this is the example of capillary tube over here in this diagram we can see. Now let's see some information about evaporator, about condenser, about compressor. Okay, so this is the unit in which electric motor and compressor is available. So what happen, compressor will suck the refrigerant. Okay, so in compressor, the refrigerant will pass through compressor by electric motor and compress it, and further it will convert into the high pressure and high temperature media. So it will pass through this channel. It is known as condenser. And over here in the last figure we can see this is the condenser. In nowadays, this condenser is covered by refrigerator body, so it is not too visible. Now from this condenser, the refrigerant will pass through this and the function of the condenser is meant to dissipate more and more heat inside the atmosphere, and further this refrigerant will pass through the capillary tube. Capillary tube basically, as we can see here, this is the tube and the cross section will reduce in capillary tube and it will like this. So the refrigerant will pass through these tiny diameter tubes, and this is known as capillary effect. So expansion will take place in these tubes. Okay, now let's discuss over here as we can see, this is our evaporator, this is our condenser. In third figure we have fins. So what is the function of fins? the fins are available to increase surface area. If we have more surface area, then we have more heat transfer. Remember. Now from fin, there are 2 points we have to remember: effectiveness of fin and efficiency of fin. So let's discuss very quickly what is the effectiveness and what is the efficiency of fin. The equation of effectiveness of fin is Kp by Ha square root. Now over here K is the thermal conductivity, unit is watt per meter into Kelvin, and H is the heat transfer coefficient, watt per meter square degree Celsius, and A is the area. And for P is P over here, P is equal to dA by dx. Now let's discuss why dA by dx. Let's see over here. Well, this is the example of fin. This is our surface on which fin is attached. Well, let's take out a small cross section from this fin. Let me zoom over here. This is the small cross section of fin. So this value is dx, okay, and this is the dA, area, cross section area, and the thickness. So P is equal to, it is the ratio of dA by dx. I think you are clear about it. Now let's discuss some more important about the efficiency of fin. Well, we have discussed about effectiveness of fin, that we know, and the equation is Kb by Ha. Now for the efficiency of fin, it is 1 upon L square root K P over here and Ha. So Ka by Hp. So there is slight difference in both the equations. Over here L is the length of fin, as we have seen in our diagram, that this is the length of fin, okay, this is the length of fin. Let me draw very clearly so you have more clear idea about what is the length of fin. Well, okay, this length, okay, this is known as L, the length of fin. Now let's discuss in which cases the effectiveness of fin is more efficient. So the effectiveness of fin, if the value of this effectiveness of fin by equation is equal to 1, then the heat transfer take place in normal mode. Now the effectiveness of fin is less than 1, then our fin will act as an insulation, so it is not good for a system. Now if the value of effectiveness of fin is greater than 1, then the heat transfer will increase. Okay, so wherever we are going to build any system, we must check in heat exchanger the effectiveness of fin should be greater than 1. Okay, I think this information is enough. Now let's discuss about some other parameters, like vapor compression refrigerator works on reverse Carnot cycle. Okay, first of all, remember the refrigerator is also the refrigerator is also known as heat pump. Remember, refrigerator is also known as heat pump. So don't confuse between heat pump and heat engine. Heat engine is basically what? An engine which convert any kind of thermal energy, or we can say any kind of chemical energy, and to convert this energy into mechanical energy. Okay, so the function of heat engine is to basically to convert any kind of thermal energy into mechanical energy. That is our heat engine, like spark ignition, like compression ignition. Okay, over here heat pump is known as refrigerator. Don't confuse between heat engine and heat pump. Now COP, coefficient of performance. Coefficient of performance of heat pump is equal to 1 plus coefficient of performance of refrigerator. Now theoretically both are same. Now if we calculate the coefficient of performance of refrigerator, then we have to add 1 and we have value of COP of HP, or we can say heat pump. Now let's discuss what are the equations of coefficient of performance. So let's see. Coefficient of performance of heat pump is equal to initial temperature divided by initial temperature minus final temperature. Coefficient of performance of refrigerator is equal to final temperature divided by initial temperature minus final temperature. So remember this difference. Now over here there is also another equation. We can see here vapor compression cycle is works on reverse Carnot cycle, but for Carnot cycle the equation is T1 minus T2 upon T1, or we can write over here 1 minus T2 by T1. Now if we want to find efficiency of the system, then efficiency is equal to 1 upon COP. Okay, remember this equation. I think this information is enough for a refrigerator. Now let's move to the next question. Well, cores are used to our options are strengthen the molding sand. Well, this is not the right answer. Now option B, support the loose piece. This is also not right answer. Option C, remove pattern easily. To remove pattern easily there is a draft. So C is also not the right answer. And option D, make desired recess in the casting. Yes, this is our right answer. Now let's see what is core. First of all, core are two types mainly, wet and dry. For dry core, bentonite is the binding material, bentonite, and for wet core, linseed oil is the binding material. Okay, in this figure as we can see, the upper portion of the casting is known as COP. Let me show you, and the bottom portion is known as drag. Now this is the portion which I am going to show you right now is known as core, and our final component from this casting, and it is also has some cavity, so this recess is done by this core. Let me clear all this. First of all, well, this core is responsible for this cavity. Okay, now this component is known as chaplets, and this chaplets is used over here to support the core, and also to support the core against buoyancy force of the molten metal. So Don't confuse between chills and padding and chaplets. There is also one core print. Core prints are the function of chaplets and core prints are same, but don't confuse between chills and padding and chaplets. Chills and padding are used to for making directional solidification. Remember this sentence. Chills and padding are used to for directional solidification. Okay, I think you are clear about course. Now let's move to the next details. Oh, this is the end of the video. Now we will upload our next video to be continued. Please press like if you like the content of the video, and also give comments because your feedbacks are very important for us. Share this video if you like this video and with your friends of an engineering branch like mechanical, automobile, mechatronics, etc. Don't forget to subscribe this channel. To join with us for next video, please subscribe this channel. We are also available on Facebook, Twitter, LinkedIn and Google+. If you like our video, then please subscribe, and if you have any query, then feel free to contact us on studymakeeducation@gmail.com. Thank you. Have a good time.